Good morning and happy Monday. So just a reminder, I'll be back tomorrow to answer any questions you have about standard deviation. But in the meantime, I figured today would be a good time to introduce you to using technology as a way to calculate mean and standard deviation. So that's going to be our focus today. I'm sure on Thursday and Friday you loved doing that by hand. And I think that's good practice so that when we do get to use the technology, we get to appreciate it just a little bit more. Um, so just a quick reminder, if you haven't finished any practice assignment up until this point, go ahead and double check and make sure you're getting those done. So just as a reminder, because it's probably been a long weekend for you, the standard deviation, that's what we're talking about here, is used to tell how far on average any data point is from the mean. So if we've got a set of data, we can calculate the mean pretty easily, but then we're looking at, how spread out is the data. So if we have a smaller standard deviation, that means our scores are closer to the mean. When the standard deviation is large, our scores or our data values are more widely spread out. So again, we're looking at it as how spread out is our data. So last week you looked at some calculations. You looked at the population standard deviation. And so that was this lowercase sigma, and it was calculated as the square root of the sum of the differences between each of the data values and the mean, all squared, divided by the total number of data values. And then we also had the sample standard deviation, which was a lowercase s, and it was nearly identical. It was the square root of all of those sums, the uh, distance between a value and the mean squared, all added up, but this time divided by n minus 1 because we're just adjusting that a little bit because it is a sample and not a true census of an entire population. So you did all that by hand. It was amazing. It was awesome. But today we're going to practice using technology to do that because it's just, it's more efficient and that's how things roll. So our practice problem we're going to look at here is a junior high basketball team played 10 games. So we're going to find the mean and the standard deviation for the number of baskets scored by the team for the 10 games. So we've got 10 data values here representing the number of baskets they scored. And so we're looking for the mean, right? And we're looking for the standard deviation. Now, if they only played 10 games the whole season, I would say this is going to be a population standard deviation. So we are going to look for that lowercase sigma, a population standard deviation. So in order to do this, I'm going to head on over to Desmos. There's a link to this at the top of your screen. So I'm going to go over to Desmos. So when you get to Desmos, we're actually not going to be using the graph at all. We're just going to be using the left-hand side of the screen. And the first thing we're going to do in this blank box, we're going to click this plus in the upper left-hand corner to add an item. And we're going to be adding a table. So we've added a table here. We've got the column x1 and y1. So we're actually only going to use the x1 here. And we're going to fill in that x1 column with our values. So looking back at our data, it was 8, then 4, then 6, 6, 7, 7, 9, 4, 8, 5. So I know that usually we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just wanted to double check. I know that usually we are looking at a table as having x and y values, but what we did here is we created a list. This list is called x1, and so we're going to be able to refer back to it whenever we want. X1, there's the name, and here's our list. So we've got our data in here. I'm going to look at the next expression box. It's 2 there. And so in this next box, we're going to calculate the mean. So there's a couple different ways you can do that, but I want to show you this one first. In the lower left-hand corner, you've got a keypad. So when you open that up, you've done this before, you've seen all these options here, but we haven't spent much time in the functions option in the right-hand corner. So we click functions, And there's actually 4 different menus within this menu. So this trigonometry menu, we'll look at a couple months there. Stats, this is where we're going to be spending most of our time the next few weeks. But we also have a set of distributions, which, oh, look, we can make a box plot, we can make a histogram. This normal distribution down here, that's going to be helpful next week. And then at the end, miscellaneous. This is just actually a bunch of really fun, good stuff. So I encourage you to check it out sometime. But today we're going to be in stats. So notice there's a couple of familiar words here. Total, so that would allow us to add up the list. Mean, that's the one we're going to be using. We could also find the median, the minimum, the maximum, the quartile. And so there's a whole bunch of stuff we could use here. But today we're going to look at mean. So I'm going to click mean. And now it shows up in my box here, and it's waiting for me to put an input in. I could have also typed the word MEAN and open a set of parentheses, and Desmos would recognize it as well. So to call back my list, remember my list is called X1. So I'm going to type in X. And then for my 1, to do that little, it's called a subscript, I'm going to do shift underscore. So close to your backspace button, and it opens that subscript, and then I just call it 1. And then when I close those parentheses, now it's calculated the mean there is 6.4. So I used the function mean, I called back my list, and it calculated the mean for me, 6.4. So I'm going to record that here in my notes. So my mean here is 6.4. So going back, now I want to calculate the standard deviation. So I'm going to go back to my menu. I'm going to go back to my stats menu. So you'll notice there are 2 options here. One says STDEV, and then the one down below says STDEVP. So because we already discussed that this is probably a population standard deviation, we're going to use the one that has P at the end for population. If we were looking at a standard sample deviation, we would be looking at the one without the P at the end. So I click on STDEVP, it opens a set of parentheses, and again, it's looking for me to call back my list. So I could either do it the same way by typing X and then underscore 1, or I can use this menu here. I can do X, then go over to this ABC, and there's my subscript. It's at the bottom, and then it's looking for me to go back and call 1. So there it is. It calculated my standard deviation. I'm going to round this to 1.625, I think. So if I was doing this multiple times, I had another data set, I would go down to my next box, open another table. And so this time it's giving me a new table. It's got X2 and Y2, so I can fill out X2 and refer back to it that way and do all these similar processes again. If you have a TI-84 or TI-83, you can also do this on those calculators. I'm not going to show you that today, but you can go ahead and go to YouTube and look up standard deviation on TI-83, and you'll find tons of videos to help you out. But this should get you going on your practice assignment here. Oops, I should record my work here in my notes. So I encourage you to go back through your notes from last week. Now you've got the technology to help you out. And once you get to your practice assignment, you will be ready to go. And just a helpful hint here for your practice assignment number 1, you've got these dot plots to represent the data. You're going to convert this into a list. So this would be 1, 2, 2, 3, 3, 4, 4, right? Every dot represents a number listed in the list. All right, so I will see you tomorrow. Please email me if anything comes up. You got lots of time now to get lots of practice done. I will see you tomorrow.